So I have this tube radio, Tesla 55C, and I have pulled out this coil and capacitor because coil was broken at one place. I've repaired that, and now I need to determine at what frequency this coil and capacitor resonate, because they should be tuned to intermediate frequency. That is the frequency that is going to be amplified in this part over here. And the reason for this coil and actually oscillating circuit here to exist is to ground any signal that would come to the exact frequency of intermediate transformer, because that could cause some interference and so on. So the goal now is to determine at what frequency this circuit resonates. It's actually a simple thing to do. This is a setup that I have already prepared. I have a source of high frequency, that is this signal generator, and as voltmeter I'm gonna use oscilloscope because I can check amplitude of the signal that comes from this signal generator, and in this case voltmeter is oscilloscope. It will serve as voltmeter. There is our oscillating circuit. It's over here to see how it looks in practice. This is the coil, and capacitor is from the bottom side, and there is this resistor. I will now explain what it's used for. There it is. It's over here. It's not important what value it would have. It can be 100 ohms, 1 kilo ohm, 10 kilo ohms. It would just change the setting on your measuring equipment. With less resistance you would have to set it to be more sensitive, and vice versa, because we will have more voltage on higher resistance. So what happens here is that when we have the resonant frequency, in theory this part here would be short circuit, so ohm resistance should be 0. In practice it's different, of course, because the coil itself has some resistance and so on, capacitor as well. So the maximum of current will be at resonating frequency. When we have the maximum of current flowing into this circuit, then we will have the maximum voltage over here, and that is our resonant frequency. So all we have to do is to determine when we have maximum voltage here. So we will just monitor amplitude on the oscilloscope. At this moment this function generator is set up to oscillate on 250 kilohertz. I expect to be somewhere at 400 kilohertz resonant frequency. So what I'm now going to do is I will slowly increase frequency in steps of 1 kilohertz, and I will monitor amplitude over here just to set it up in the middle. It's old analog oscilloscope, so it changed its values during the time. Okay, now that works okay, and I'll start increasing. We can see that amplitude is rising. We'll have peak at one point, and there it is. As I increase the frequency, it goes down. So this is somewhere where we have resonant frequency. Let's see, it's over here. Yeah, that would be 296 kilohertz. We are way below, so we need to reduce capacitance. I can change time base. Maybe it's easier to see when we don't watch wave shape. That should be it. Now you just watch for the amplitude. Goes up, down, and there's the maximum. So yeah, it's somewhere about 297 to 96 kilohertz. So my next step is to tune it. I'll try first with capacitor itself, because its value can be changed, and of course the coil stays as it is. It would be very difficult to do anything with it, but not impossible. And I will now deal with this. But anyway, you saw how simple it was to measure this frequency. I can add some capacitor here, and I can use that in calculations to determine how much capacitance I need to add in serial. That would reduce resulting capacitance, that would increase the frequency, and so on. But that's another story. That was just for you to see how easy actually is to measure the resonant frequency when you have a signal generator and oscilloscope.